In section 2.1, one of the things we did is problems like this. For the table below, find the slope or rate of change, include units where appropriate. So don't get thrown by this concept of rate of change. That's really just slope. We want to get you used to that, hearing that term rate of change. It shows up a lot in other math classes, and so we're just starting getting you used to that. So when you find the slope of something like this from a table, remember that slope is always just rise over run. And then also remember in a table, the top line, just the convention that we use in the book is the top line is x, or the independent variable, and the bottom line is y, or the dependent variable. And so rise over run is going to be the change in y over the change in x. So the way we're going to find the change in y is we're going to do 39.20 minus 19.60. And then to find the change in x, we're going to do 40 minus 20. So that comes out to be 1960 on the top and 20 on the bottom. And so that turns out to be 0.98. And then remember, we were asked to include units where appropriate. Well, they are appropriate here because we have units right here and right here. So the things on top were dollars, and the thing on the bottom was square feet. So this 0.98 is dollars per square foot. You also, in section 2.1, wanted to get used to the idea of what in general do slopes look like. And when you have a positive, negative, zero, and undefined slope, you ought to be able to go back and forth. So you ought to be able to look at a line, tell me whether it's positive, negative, zero, or undefined, and I ought to be able to ask you, what does a negative slope line look like, and you ought to be able to tell me that. So remember that a positive slope line rises from left to right. So it's going up as you move from left to right. A negative slope line, the opposite. It's going down from left to right. A zero slope line is flat. So make sure you know that. You have to know the difference between a zero slope line and an undefined line. An undefined slope line is a vertical line. So you need to be able to also look at a graph. So earlier we looked at a table and found the slope or rate of change. And here we're going to do that using a graph. So again, always remember slope is rise over run. Now the place where people get in trouble reading off a graph is because we start you out that way to make it easier, you get in the habit of counting squares to count rise over run, and just remember that that's fine, but you have to remember that not every square is equal to one unit. And so if you notice on this graph, when we go from here to here, for instance, we actually went, I don't know if you can read this, but this is a 400. So this is actually 100 units. The units on this one's hard to see, but it's dollars. So if we go down a square, we didn't just go down one, we went down 100. So you just have to keep that in mind as you're doing rise over run. But otherwise, you do just visually look at it and figure out Remember, you pick a point to the left. So I'm going to pick a point that's easy to see what the coordinates of that point are. And then I'm going to find another point that's easy to see the coordinates of, and that's this one. And then I move from the left-hand point to the right-hand point and think, what did I have to do? How much did I rise and how much did I run to get from the left-hand point to the right-hand point? So the rise in this case is really a decrease of 200. So I went from 500 to 300 to get from here over to here. So that decrease of 200 means a rise of negative 200. In other words, the vertical change is a negative 200. And then the run, the scale on the x-axis is just one, and it's year per square. So I moved over 3 squares to go this direction, and so I get 3 on the bottom. So we were asked to include units. The units on the vertical axis are dollars, so that's dollars up here, and the units on the horizontal axis, where the run is years, so this is per year. Now, that looks kind of funny to leave it in that fraction form like that, but I'm going to leave it that way because I do want you all to get in the habit for right now of leaving slopes in fraction form. This is one of the ones that if you tried to reduce it to a decimal, you'd have to round it off because 3 doesn't go in evenly to 200. And for right now, I don't want you to round things off. I want you to leave fractions as fractions. Later on, we'll talk about specific instances where even if you have to round it off, you want to go ahead and divide it. But I don't want you to do that now. If you come out with a fraction as an answer, make sure it's reduced as far as possible, which this one is, but don't make it into a decimal. If we ask you on a word problem to round to the nearest hundredth or round to the nearest tenth, or that sort of thing, then that's your direction to make it into a decimal and round. But in a case like this, I'd rather have you leave it as a fraction. Even though I know it doesn't look like it makes much sense that way, negative 200 over $3 per year, what does that mean? But we'll talk more about that later. I want to make sure you know how to graph streams looking lines like x equals 3 too. If you have a thing that's x equals 3, there's a couple ways you can approach this. You can try to really understand why the graph is what it is, or you can just memorize what a graph like x equals something looks like. So first of all, I'll just show you what this looks like. So the graph of x equals 3 looks like this. Now if you think about it, so that's if this is the x-axis and this is the y-axis. Make sure that whenever you have a little graph like this, that you always mark your axes and also give an indication of scale. So if it's really small like this, you don't have to mark every line, but do give some indications of scale, so that, because otherwise your graph is meaningless if I don't know how many units each square stands for. So this is x equals 3. If you want to understand why, think about that every point along this, let's take this point right here. So this point is 3, 4, and if we look at this point down here, this is 3, negative 3. And what's important about that is you notice that everywhere along that line, the x-coordinate is 3, and the y-coordinate can change and be anything we want, but that's why that's the graph for x equals 3, because that's the set of points where no matter what y is, x is always equal to 3. So if we answer the question, what's the slope? Well, you already know a vertical line has an undefined slope. And the y-intercept, that's where it crosses the y-axis. Well, it doesn't cross the y-axis, so it doesn't have a y-intercept. So alternatively, if we want to graph y equals -5 instead of x equals 3 like we had before, this is a y equals -5. It's the same concept. So I'm going to make a couple of marks here to mark our scale. This is x and this is y. So now that I've got all that marked, so I know what all this means, y equals -5 looks like this. And again, it's because along that line, x changes, but y stays the same. And it stays at -5. So what is the slope of a horizontal line like that? Slope is 0. And what's the y-intercept? Well, it's where it crosses the y-axis. That's -5. So be sure you're comfortable with that with vertical and horizontal lines in addition to finding slope on just normal lines that have all kinds of different slopes.